Hi everyone, I'm Stuart, and today I'm going to be talking about C# 10, a sneaky peek. So just a little bit about me. I'm Stuart. I'm a father to Microsoft MVP and principal engineer at Just Eat. I blog at stu.dev, and that's where you can get hold of me. You can grab me on Twitter. My DMs are open if you want to chat. And I love C#, F#, and all things .NET. Today is about C#. And as the title suggests, it's a sneaky peek. So C# 10 isn't out yet. So a kind of disclaimer that anything I talk about today should be fairly representative of what will land, but there is a chance that Microsoft might need to pull something last minute because of a show-stopping bug, or they might tweak the design a bit. But hopefully this should be quite representative of what we'll see. So just to kind of step back a bit and say, where are we? This is the kind of timeline of releases that Microsoft have put out. We are currently here. We have .NET 5, and in November, we're going to get .NET 6. And that's Microsoft's new kind of release cadence now. Is every single year in November, we'll get a new version of .NET. We'll get 6, 7, 8, etc. So it's nice and simple now. And that's also how Microsoft will be shipping versions of C#. So major versions of C# will also ship with these releases. So we're on C# 9 now, and we'll get C# 10 in .NET 6. So you can kind of add 4 to the .NET version to get the C# version. This diagram also shows the long-term support release plan. So these top dots represent the long-term support releases, and those have, as the name suggests, a longer support window. You might be in work environments where you're constrained to only using these releases. And if that's true, then .NET 6 is super exciting because it's not just a step up from .NET 5. You're actually moving from .NET Core 3.1, which is currently on C# 8. And so you're going kind of 2 .NET versions and 2 language versions. So you'll get all the C# 9 goodness as well. So that's kind of exciting. If you want to code along today, or just try out C# 10 after the talk, there's some great options for you. We've got .NET 6 release candidate 1, which is out very recently, and that's a go live release. So if you want to actually put that out in production, you'll get support from Microsoft if you want to do that. You can get it from this link here, and this is the same link you'll find if you do a .NET -- info if you have a current release. When you do that, you'll need either VS Code with the latest OmniSharp C# extensions, and that'll work with C# 10, or you'll need Visual Studio 2022 Preview 4, and that's all lit up. The C# 10 functionality is lit up in that version. If you don't like having sort of preview SDKs installed on your machine, that's fine too. A really good option for you if you're on Windows is to install LinkPad 6, which is in beta, and it has this great option, the preferences, for use Roslyn daily builds. If you check that, you'll get daily builds of Roslyn. You can try out the latest C# 10 features as they land, which is great. And if you can't do either of those, sharplab.io is a great website. I'll be showing that later. It's a great way of sort of trying out little things. You can even try out feature branches of Roslyn for things that haven't yet landed. And what you can do there, I'll show later, but you can go into sharplab.io, and there's a drop down where you can select the main branch, and that gives you all the latest features. So that's a really good option as well. One caveat with that is that it doesn't ship with the actual latest .NET 6 runtime. So some features may not quite work. There may be types missing that you might need, but it's a really good compromise if you want to just, no strings, have a little play with this stuff. I'm going to get straight into C# 10 features. So like the first one I'm going to start with is one of my favorite ones, which is file scope namespaces. So this feature, I'll just bring that slide up. Here's what a typical C# file looks like. You've got a namespace, you've got a class, and then you've got members. And if you had methods in here, you'd have even more sort of indentation at the side here. And there's a lot of wasted space in this indentation. And particularly for the namespace, this indentation is kind of typically on every file in our solution. And so there's a lot of kind of real estate that we can kind of claim back if we had a better way of kind of handling namespaces. And that's what we're going to get in C# 10. So the language team have come up with a feature called file scope namespaces, but that's the kind of feature name, but the syntax feature is something called a namespace declaration. So we'll be able to turn this namespace kind of block at the top here into a namespace declaration by adding a semicolon at the end. And when we do that, we can take away the coded braces. And now for the entire file, everything beneath it is implicitly, well, it's explicitly in that namespace. And so we get rid of that indentation, and that's excellent. It's a straight win. They are shipping a Roslyn analyzer or Roslyn code fixer for this, so you'll be able to kind of click on the light bulb, apply it to either the file or the project or whole solution. When you do that, if you look at the diff there, obviously it's going to touch every file in your solution. And there's really three characters that change. There's adding the semicolon and removing the two coded braces. But obviously it's going to change all the white space as well. So you're going to have a massive diff there when you put that in. So depending on how painful merge conflicts are, like be careful when you merge that in. But I'm really excited to apply this to lots of solutions. One thing, the reason I love this feature is because usually with language features, there's some kind of trade-off involved. And I feel for this one, there really isn't a trade-off. It's just a straight win. Something else to say is that this is actually the default now in the new template. So when you have a .NET 6, when you say .NET new and create a new project, this is what C# code files will look like. They'll have this namespace declaration. A question you might have around this is, what would multiple namespace declarations within one file mean? And the language team themselves couldn't decide. They were split down the middle. Some felt that would be a nested namespace. Some people felt it would be an adjacent namespace. And so they realized that there really isn't an intuitive answer to that question. So for that reason, they're not going to allow it. They're going to make it a compiler error if you try and have multiple. And if you want multiple namespaces in a file, which generally we don't, but if you do, you can use the old syntax with the coded braces, and that way it's explicit. So that's just a really nice feature. On a similar kind of theme, we have global usings. So if we take that same file that we just looked at, we've tidied up the indentation on the left-hand side now. But on most C# files, we have the using namespaces at the top that we need to bring in. Now in this file, we have a string and an int property, and those are compiler aliases to system.string and system.int32. So we don't need any namespaces brought in. But let's say we added, a collection or a datetime property like this. We end up adding in what I like to refer to as the usual suspects, and that's like system generic collections, system threading tasks, and in this case, I'm not using any async code, so system threading tasks is kind of grayed out, and the IDE wants me to get rid of it. But I know that I'm going to be adding that back in like 10 minutes later, so I end up sort of having to do this kind of bookkeeping where I'm changing the same lines of code, adding in the same using statements, and removing them over and over. And so it's kind of, one, it's a wasted space at the top of the file. Two, is this ongoing bookkeeping of the same namespaces. And three, it's also churn at the top of the file in the same place that my colleagues are changing, in the same files my colleagues are changing code. And so we're all changing the same top lines, and we're all having merge conflicts. So the language team have kind of solved this with a new feature called global usings. So the new syntax they've added, you're able to say global using system. So if we add that to the top line here, we said global using system, for the rest of the project, in every other file, implicitly using system would kind of be brought in for us. And if you were to do that in this kind of arbitrary file, you're a maniac, because if you had these things scattered around the whole project, it'd be hard to keep track of. So what you'll want to do is have these all in one place. And Microsoft suggests you have something like global usings.cs, where you keep these. So here we've moved those out to a global usings.cs. We've got all the usual suspects. And now in each of our code files in our project, we can just write the straightforward code. And now we've kind of tidied up the cruft at the top of the file, which is nice. Anything you can do with a using namespace, you can do with a global using namespace. So for example, you can do like using my alias equals some type and do a type alias. Also in this example here, if I shift my head out of the way, you've got using static system console. That brings in all of the static methods on the system console class. So you can do that with a global using as well. So anything you can do with one syntax, you can do with a global. It's kind of cool. Now, as well as this functionality, they are also kind of leaning on this in the SDK itself. So in the .NET 6 SDK, they're going to ship some defaults, some sort of sensible defaults. And this is a very recent change. So in the version 7 preview, this was kind of on by default. And what they found was a lot of people complained because they were migrating their .NET 5 projects and suddenly had lots of compiler errors. This is now opt-in. So if you're upgrading an existing project, you need to say implicit usings enable. But this is actually included in the new template. So if you if you create a new .NET 6 template, .NET 6 project from a template, this will get included automatically. So it's on by default for new things, but you have to opt in for existing things. And what this does is inside the SDK itself, there's this guard that this properties now let you into. And it lets you into this item group that has these using items. And this is a new thing. So these are the namespaces that kind of ship. And what will happen is these will get converted into auto-generated code, just like your project properties get turned into assembly info attributes. A similar process happens here. So this will end up in your obj folder as like global usings.g.cs, and it will contain something like this. So by opting into that in the project, you'll now get these implicit usings. And this is what you'll get for a console app or a library. If you are targeting a worker, you'll additionally get these top 4 namespaces here: Microsoft extensions, configuration, dependency injection, hosting, and logging. And if you're targeting a web application, you'll get even more. You'll get these top 4 here, which is Microsoft ASP.NET Core, builder, hosting, HTTP, and routing. You also get this one, the sneaky little one here, which is systemnet http.json, which has lots of extension methods around HTTP client for serializing and deserializing JSON content. And with that project sort of driven approach, so obviously you had the global usings.cs approach where you have that in your project. If you were to do this approach instead, you can actually do everything you can do in the code version. So for example, you can have an alias equals something and it will code generate the equivalent C# code. Same for static. If you say static equals true, you end up with a global using static. So that all kind of works. An advantage to this approach is that you might have this in your directory.build.props, and then you can have it solution wide. Another thing you can do with this is you can ship this in your own NuGet packages. But you should think very carefully about doing that. As Microsoft have found, if you start shipping these things by default without an opt-in, users get angry. So if you want to do that, let's say you're like I don't know, let's say fluent assertions, you've got some namespaces that you think, here's a sensible bunch of namespaces I want to package up and I want to ship to people, then go ahead and do it. But definitely have that property guard in there so that people opt into it. And just on this feature in general, there are some trade-offs here, and one part of it is kind of this sort of a bit of indirection or misdirection. Something's being hidden away a little bit. But I think it's really great because it's the same sort of namespaces in all our code files that really is kind of a fragmentation. I've got system.link everywhere. Like, why isn't that just a given, right? So, but I like this one a lot. And again, this is on in the template by default. So new C# code will start looking like this, where the namespaces are kind of, you have some sensible defaults there. The next feature I want to talk about is record structs. So in C#9, we got records, and it's probably one of the headline features of C#9. Records are a way of defining a type with a different set of defaults that are better suited to value objects in domain modeling terms. And they have a different set of defaults, and they have sort of structural equality or value-based equality. And this is what the syntax looks like. So for plain old records, you'd say record coordinates, and you have this new short form that they introduced in C#9 where you could put a semicolon at the end and you pass it some some parameters, and it would sort of extrapolate properties from those parameters. If you didn't want a constructor on it, you could actually put those parameters in yourself, and you'd do it like this. And you would do it with these init properties. So rather than a setter, you'd have the init keyword. This is a new thing they added in C#9 as well. And again, that's what this will automatically generate. The init properties are basically immutable properties, but they can be set in the object initializer expression when you new it up. So that's the kind of syntax from C#9. What they realized in looking at record structs in C#10 was maybe they got the framing a bit wrong in terms of the kind of what record means. So in C#10, they've kind of rethought it and decided that, you know what, record is actually a modifier. So you can now say in C#10 record class coordinates, and that's the same as if you said record coordinates in C#9. But of course, for backward compatibility, record coordinates still works. So it's just implicitly a record class. But the way you should think about it is record is a modifier for class. And in C#10, the new feature is record struct. So we can now say record struct. So record's a modifier for a struct. And again, you've got this, you've got this short format where you can just put the semicolon at the end and put in the arguments, and it's just going to create the properties for you. If you've used records from C#9, record classes, then this does mostly what you think it would do, with the exception of immutable properties. So in the previous slide, these properties were immutable by default, but we've already got away with structs in terms of opting in and out of immutability. So if we want immutable record struct, we have to say read-only record struct to be consistent with the existing syntax. So if you just say record struct, it'll be immutable properties. You probably want your records to be immutable for reasons I'll explain in a second. And you do that by read-only. So read-only record struct is what I'll be using. If we look at this SharpLab example, I hope will explain some of this. Here's an example I made earlier. Don't worry if you can't read this text. I'll try and explain it. So on the left-hand side, let me introduce SharpLab before I go off and get ahead of myself. This is sharplab.io. It's awesome. You've got this drop down where you can change what branch it's using. So if you change it from default to the Roslyn main branch, we can start using the C#10 features. So here I've defined a record struct, and I've changed the results here rather than run to C#. And this shows us the sort of decompiled version of what this code generated. So we can see what that actually translates to. And this record struct, if we look down here, it gives us a compiler generated struct, and it gives us these properties extrapolated from the Latin long here. And they're mutable, as you can see here, with the get, set, and the backing field. What you get in a record is you get the constructor here created for you. You get a pretty two-string method that pretty prints the members. You get the equality operators and method and inequality operator that's based on value equality. And you also get a hash code, get hash code implementation that matches that equality, sort of value-based equality. And this is an important reason why you want your structs to be, your records to be immutable, because now if you change a property on a record, you've now changed the hash code. So say that record was a key to a dictionary. As soon as you change a property, you've basically changed the hash code, and now you've kind of orphaned that key in that dictionary. You can't get the value back out. So that's one reason why you typically want your records to be immutable. You also get, with the short form, you get the deconstructor. If I shift my head out of the way, you get the deconstructor that goes with the corresponding constructor. Something else you can do with records that you could do with that you could do in C#9 is with this commented out example up above. I'll switch this to run. You're able to create a record, and you can't mutate the immutable properties, so you need a way of kind of working with them. And so they added the with expression that lets you copy an immutable record with a change. So you create a new one with that property change. So here we're changing lat to 4. You see the output here. Basically the way this works, the compiler needs to know how to clone that object. And so for record classes, one of the auto-generated bits of code you got was the clone method that it would create for you. But in structs are inherently clonable because they're copied by value. So they didn't really need to build anything in terms of the code generation. They just needed to allow structs to work with the with keyword. And in fact, they decided, why not just make any struct work with the with keyword? So if I change this, and it'll be too slow, but if I change this coordinate from record struct just to a plain struct, this syntax would still work. I'd still be able to copy with the change. And so that might be useful if you already have existing structs out there, you didn't want to convert to record structs. Also, they've allowed this to work with anonymous objects. So when you say like new, anonymous object, the compiler inherently knows how to clone those things. So you can also use the with expression with those anonymous objects, which is kind of cool. Let me go back to the slides here. There we go. There's definitely a full-length talk to be had on records, and David Wenger here has done a really good one for, I want to say it's NDC Melbourne. Yes. If you want to know more, he goes into a lot more detail and probes at the the generated code, and yeah, it's a really good talk if you want to know more. I said at the start, my favorite feature was namespaces, the file scope namespaces, but this one probably actually tops that. So better lambdas. Lambdas were introduced in C#3 a very long time ago, and they were there to sort of enable link, which is probably the most fundamental change to C# ever, I would argue. But really, they haven't changed that much. Lambdas haven't really changed since then. They've had a few minimal tweaks here and there. And there's a few sort of usability issues with lambdas. One of the issues is that there's a big feature gap between lambdas and methods. Things like you can't have attributes on parameters, you can't have in-out parameters, return types, lots of little things that just, there's a big gap there. And the other one is that you can't really use lambdas. Like you can't just define a lambda on its own. You have to cast it to either an expression or a delegate. And just to like make that clear, here, if we wanted to just have a lambda that, we just said, hey, I want a lambda, call it F1. We have to do it like this. We have to kind of cast it to a delegate type, or we'd use the constructor, delegate constructor, to do that for us. And that's why, like, when you have link and you have the select method is expecting a generic delegate, and that delegate is what's casting your lambda into something that method can accept. But when you try and pull it out into a variable, you end up with something like this. We don't do this because it's super ugly, right? But that's something they're changing. So this is, I think this is amazing. So in C#10, we'll now have natural inferred types for lambdas. So going for this example here, on this line here, we've got for F4, we can just write a lambda, and C#'s now going to infer a delegate type for us, which is awesome. So in this case here, it'll infer a func of int. Likewise, on the next line, we'll get an action of int. If we use async, it's going to infer a task. So we get func of task int here. We can also use this with method groups. So here we've got one.get hashcode. And without the brackets, that's a method group. And so we can just it'll just take that and cast that, and infer that delegate type for us automatically. And this is actually one of the source of a few little bugs they're trying to iron out in time for C#10. So hopefully this doesn't cause any issues, and this will land. And yeah, and finally on that last line, 1.toString, because this is int toString, there's lots of overloads for int toString, so it won't know which one to pick. So the method group scenario will only work where there's one overload, which makes sense. Now, if we look at the ones that won't work here, that if we go from the top, we've got F1. We're returning a null here, so the compiler's not going to know what that type is. So it could be a reference type, it could be a nullable value type. It doesn't know. On the next line, we haven't used X, And so it doesn't know what X is. We have to tell it. And it's not like F#. It's not going to sort of do this functional programming type thing where it follows where you're passing a parameter and sort of infer from the usage of it what it is. We have to tell it on the inputs. Also, another feature from F# we won't be getting is this one here, where you take some X and return X. In some languages, this may get auto generalized, so that this would take a T and return a T and be generic. Not here. So we have to be kind of explicit in terms of the input types. But on that previous example, at the top line, we're returning null. They're also allowing us to have return types for lambdas, which is again new. And this is closing that gap on methods. So we can now define just like in a method what the return type is, and we put the return type left of the kind of parameters, just like in a method. So now it can infer that this is a func of string. One thing you may be familiar with lambdas, where you have just one argument, you can omit the braces, the brackets. Well, that's not true with return types. The compiler can't quite figure out the can't quite do the sort of compiler parsing gymnastics required. So whenever you're using a return type, you always have to have these braces in, even if it's just one argument. So something to bear in mind. Something else they're doing to close that gap on methods is parameters. Sorry, attributes. So you can now have attributes on parameters and on the Lambda itself, just like you can have a parameter, sorry, an attribute on the on a method. And so here, I'm bad at naming stuff. Here are my fake attributes. You can also have an attribute on a return type by having putting return colon here, just in front of the name of the attribute. And so that's super useful for reasons I'll show in a second. In fact, I'll show them now. So all of these features kind of come together. A lot of the C#10 features in particular, they're all driven through David Fowler and the ASP.NET Core's desire to have this new lightweight way of defining ASP.NET Core APIs. So lots of other languages have really succinct frameworks for building APIs. So succinct you can kind of just take a small screenshot of a snippet of code and put it on Twitter, and people can immediately see it and get what it's doing. And that's really appealing to new people coming in, because they can feel like, yeah, I could build that. I get what that does. And so that's kind of one of the use cases that all these features drive. So all these features kind of come together. So we've got, and this one's from C#9, top level statements is the ability to just write code in your entry point file with no namespace, class, or entry point method. You just write code. We'll see that in a second. We've got global usings, which helps tidy up the sort of namespace kind of scattering that's happened over time with ASP.NET Core. We've got the inferred Lambda types I've just shown. We've got the attributes now and the return types, the explicit return types on Lambdas. And now with some ASP.NET Core API changes to kind of take advantage of all this, we've got this new thing called minimal APIs, which is, this is like the headline thing of C#10 in my opinion. This is really cool. So like the simplest API, and they keep evolving this. Last time I showed this talk, this was 4 lines of code. It's now 3 lines of code. This is like, and what's really cool about this code, this is the one CS file in your project. This is it. And this isn't a snippet. This is the whole file. Like that's line 1, 2, and 3. And so you create your web app. And so this is using top level statements. So again, there's no main method. There's no program class. It's using implicit namespace, global namespaces. So we've got all the ASP.NET Core stuff up here and system and it works. And we also have the Lambda improvements here. And I'll show that in a second, explain why that's important. But previously, before the Lambda improvements, you couldn't do this. It just didn't work. And so obviously this is a very simple example. This is like the simplest thing you could do. So we want more involved examples. You can kind of grow this up. So you can actually do like, you can do so much with this, like pretty much anything you can do in MVC, you can do with the minimal APIs. It's very, the feature parity is high. So here's a more involved example. This is taken from Damien Edwards on his GitHub. And this is kind of a to-dos sample app. What's kind of cool here is that we could, so one of the improvements is Lambda improvements, and we could have attributes on parameters. So here we could have attributes in here. We could, on the to-do DB, which is like a data context thing, we could put an attribute on there to say from services, and it would pull that from the service collection. We could be explicit about it. But actually, the defaults are smart enough that it's going to know that because we've got to-do DB in our service collection, it's going to just resolve it from the DI. So it's kind of cool. And again, this will automatically be taken from the root. But again, you can have a parameter, an attribute on that parameter and say from root or from body or whatever. You can also have an authorize attribute, for example, here. But also with kind of this style of API, it's probably more idiomatic to use extension methods. So you could have an extension method, and there is one for like .authorize. So you've kind of got this, these really nice fluent API builders, but you've also got the attributes as well. And in terms of the body here, there's a new iResult type you can return, which is a bit like an action result, I guess. So you can return OK, for a 200 OK with payload. I don't know, this is really nice. I like this a lot. There's lots of other examples. This is again taken from Damien Edwards. This shows validation. He's just today renamed his validation library that leans on the data annotations attributes in .NET in a little library he's called mini validation. So this isn't coming out of the box, but this is a little shim that Damien Edwards has made. And yeah, in this case, to do isn't in the root and it's not in the service collection. So it's going to try and deserialize that from the body on the post request. So you can see here, there's, I don't know, this is really nice. And this is growing really fast, and it's leaning on all of the language features I've shown. It's super cool. And you could, of course, you can take some of these things and take them out into static extension methods. And so it doesn't all have to be in one file like this. It can start out like that and you can grow it out. It can still be very modularized, but you're in complete control, and it's all driven through the language. It's not driven through, MVC is very convention based, but here it's driven very functionally through the C# syntax. And so you're in control how you want to kind of abstract things, if you want to abstract things. It's kind of cool. This is how it works. This is how this is why the Lambda implicit sort of natural inferred type for Lambda is important, because in the existing API, you have this extension method where you would pass it a pattern for map get, and you would pass it a request delegate. And that request delegate, as I said before, was casting whatever Lambda you'd have in there. You could only have a request delegate Lambda. But now, because we have inferred, natural inferred Lambda types, we can have any old delegate in there. And that means we can pass in any old Lambda. And at runtime, the ASP.NET's core's job is to now figure out how to bridge the gap between your Lambda and the thing. So if I go back, this Lambda that just returns, this is func of string, it's going to know, oh, that string is going to be plain text, and it's going to kind of bridge it. Before, we had to cast this Lambda as the request delegate. Or, if we were doing this in C#9 with the new APIs, we'd have to cast this Lambda with a delegate, which would be super ugly. So this stuff it all plays really nicely together. That's what I'm trying to say. Okay, next feature I want to drill into is something called CallerExpression attribute. So this is a bit of a nuanced one, but it enables a really important feature that I'm going to be using a lot, I think. So there's a set of attributes that already exist in C# and .NET called caller attributes. And the ones that exist today are caller member name, caller file path, and caller line number. And what they let you do, if you haven't used this before, is you can add one of these attributes to a parameter in your method, and the compiler forces you to make that parameter optional. You have to set it to default to null. And that's because in the call site, you're not allowed to pass that value in. And that's because the compiler itself is going to pass it for you. And it's going to pass the value based on what that attribute is. So for caller member name, it's going to be the method call site that you're in, the name of the method from the call site, or the property name if you're in a property. And in this example here, we're in a top level statement. So the method is main dollar because it's an unspeakable name. But if we're in some more normally named method, that would be the name of that method. And these sort of attributes are really good for sort of debugging purposes, because they can kind of, you often see these used in sort of assertion libraries because they tell you, this went wrong, like in the exception message for the developer, here's this method called this line number, it went wrong, go fix it. And what they're adding in this version, and this attribute, by the way, has been around in the APIs since .NET Core 3, but obviously the language hasn't had the functionality for it. So, but if you're multi-targeting, that's useful to know. So what you can now do is have a CallerArgumentExpression attribute. And this is different from the others because you have to pass it the name of another parameter. So in this case, I'm passing the name of this string input. And just like the other attributes, it's going to not allow us to set that parameter at the call site. But what it's going to pass in for us is the expression of that parameter as it appears in the source file. So to be clear here, where we're using input expression, we're just throwing an exception. That exception in this case will have the string something as null, which is that expression that was passed in. And again, this is like super niche. You may be thinking, why would I care about this? And a really useful place you'd use this is, again, in an assertion library, where you want to be able to say, assert this, and in this example, except this is not null. You want to be able to show the developer, here is something we expected to be null, and it wasn't, like, and here's that expression. But where it's going to be super useful is in .NET 6, in the actual framework itself, they're going to ship a new static method called argument null exception dot throw if null. And this just takes an object argument and this new call argument expression parameter name. And so what this will do for us is we can now just say argument null exception, throw if null, and some input. And it's going to do that null check and throw a null argument exception if it's null. So this just like tidies up your code. It's shorter. A friend of mine pointed out that if you've got code coverage, your code coverage goes up if you use this because there's less branches. So this is a really nice thing they've leaned on here. I think it's kind of cool. I'm using this a lot. You may think, oh, I've seen this before. I've seen like a guard library that does this sort of thing. It won't be as good as this because it's always required someone to pass the name, and usually use name of. But now the compiler is passing us the name. We're making the compiler do it for us. So super nice. I really like this. String interpolation improvements. So we've got a couple of little features around this. The first one's a very simple one, which is const string interpolation. So you've never been able to do string interpolation with const strings, i.e. strings that are compile time static. And that makes sense if you were mixing them with non-const strings, but if you were only mixing, a string literal with a const string, it's all compile time static, so it should be able to work, right? And that's what they've allowed now in C#10. And I think a common place where we might use this sort of thing is, with attributes. So attributes have to have compile time constant values, like this. And so if you want to be able to do string interpolation with those, you can, but now you can in C#10. So you'll be able to do this sort of string interpolation with values that would go into attributes, or just wherever you might want to use a const string. So that's just a little nice one. Another place where string interpolation is getting improvements is by something called string interpolation handlers. Now, odds are you're not going to need to know this. This is almost sort of trivia, but I find it super interesting. So they've introduced this concept of string interpolation handlers, and basically it's a type you can build yourself, or they can ship, and you put an attribute on it to say it's a string interpolation handler, and it's one of those types where the compiler needs it to be a certain shape. It's not an interface it has to implement, but it kind of has to have certain rules. So it needs to have an append literal method. It needs to have an append formatted for all the types it's going to support. It needs to have a toString and clear method. And the compiler will also enforce rules about the constructor. And I won't go into full detail on this. It's just not necessary. But one way you can use this is you can overload a method that would take a string with a method that would take a interpolated string handler. And when you're using string interpolated strings, though, that overload would win, and you could then do something with that string interpolation handler yourself. Now, the odd side is you're not going to want to do that yourself. The sort of use cases are very edge case. And an example they've given in a blog post recently is you might want to, a really good example is like, I keep using assertion libraries as my example, but in an assertion library, you may want to say, assert this expression is true. And if the expression is false, then throw an exception with a message in. Well, that message, you wouldn't want to be materialized in the case where it was true. You'd only want it to be materialized when it was false, and it would throw. So you could use a string interpolation handler to kind of defer allocation of that string builder and avoid kind of evaluating the holes in the string interpolation, all that sort of stuff. But park that thought for a side. Like the more kind of commonplace we're going to be taking advantage of this is is in the framework itself. So Microsoft are shipping this here, this default interpolated string handler in .NET 6, and I'll explain why that's good. So bear with me. So we commonly do string interpolation like this. We interpolate various values together. And what happens at compile time is the compiler goes through a phase called lowering, where it kind of rewrites your code into more messy C# code before doing the real compilation. And a string interpolation often gets lowered to string.format and then like this, right? My head's in the way. And in this case, string.format isn't particularly performant. It's not bad, but it could be more performant. And in this case here, the second argument here is an int. The first one's a string. So the only overload of string.format is going to be the object overload. And so that ends up boxing this integer. And so we pay a little performance cost there. And it's nothing to lose sleep over, but this all adds up, right? We do string interpolation a lot, so this could be better. So what's happening in C#10 is if the compiler can find this well-known type called default interpolated string handler, which they're shipping in .NET 6, so we'll find it in .NET 6, it will use that for the lowering method instead. So it won't use string.format in this case. It will use this. It will do this. Excuse me. Let me move my head. This new default interpolated string handler. And things to call out here are it's a ref struct, so it's not going to do any heap allocation. It's stack based. The way it's actually implemented, it can have a span as a field because it's a ref struct, and that span is going to borrow an array from the array pool, and it's going to give it back when it's done. So it's highly performant, and more importantly here on that append formatted method. If I go back 2 slides, you can see it's generic. So when we append second, which is an int, it's not going to cast it to object. It's not going to box it. So this is more performant. So just for free, just by retargeting your project to .NET 6 and to C#10, things just get faster, ever so slightly. But yeah, really nice. And again, this is important because it's not that this really costs us too much. It's just that we do it everywhere. So everything just gets that bit quicker, which is cool. Patterns is something that they've really improved upon since patterns were introduced. And I can't remember when it was introduced, but in every subsequent version of C# they've added more and more patterns. And in C#10 we've got this extended property pattern. And this is a little one, but again, just a little nice to have. So before, if we wanted to check a nested property, we might have to do this, where we do curly braces, some property, curly braces, some other property. We can now just in C#10 just dot through a deeply nested object. It'll be null safe and it just works. So a really simple one. Something that slipped that won't be making it into C#10 is list patterns. This is one of those ones where they asked for some feedback and people weren't entirely happy with it. So they're going to go back to the drawing board. We might get list patterns in C#11 to be able to say like match on this exact list or the length of the list, etc., etc. Required properties. So this is something that's coming in C#11. It was originally aimed at C#10, but just didn't quite make it. And so to explain what required property solves, I kind of need an example. So here's an example. Here's a simple class with a property name, a property called name. when I'm migrating code to adopt nullability, which came in C#8, one of the problems I have is that I often have classes that don't have constructors. And when I do, I kind of have this implicit rule where a property is non-nullable. And so I want people to set this name property. But the language feature doesn't allow me to. Like at the moment, if I switch on nullability, I'll get a compiler warning saying, or nullability warning saying, you can't have a non-nullable string here, a non-nullable string property, because you don't set it in the constructor. And so there's nothing to express that whoever news this up in an object initializer needs to set that property. I want them to be able to say, I want to be able to say that they need to set it. And that's something that just doesn't exist. Now, they had the init keyword in C#9 that I showed earlier, and I kind of thought that might solve it, but it doesn't solve it. It only means that you can only initialize that property. You can only set it during that initialization phase in object initializers and not after it. But it doesn't mean that you have to. And that's the thing I need to express. I want to say that you have to set this property so I can satisfy that nullability error. And that's what they're adding in C#11, hopefully. So they're adding this required keyword. So by now saying it's a required string, you're saying that this has to be set. And now that satisfies my nullability constraint. So I really want this. I really need this. There's lots of little libraries I have that I don't have constructors in my DTOs, and I just want to be able to scatter some required keywords around to fix it. I was confused by this initially because I didn't understand why you could have a non-nullable string, i.e. it's not optional, and have it be required, i.e. not optional. So it's like required. And I was watching a talk from Mads Torgersen, and he explained that actually these are really orthogonal concerns. So just to make that clear, you could also do this. So for that pet's name, naming stuff's hard, by the way. For that optional pet's name property that's nullable, I can also say it's required. So in this case, what it means is, although it's nullable, so you can set it to something that's null or something that could be null, you're still required to set it during an initialization. So when you new this object up, you have to set it. And you could set that explicitly to null. So the idea of making something mandatory in terms of whether you set it or not is different from what type of value you can set it to, whether it can be null or not. So hopefully that clarifies how those things relate to each other. So I'm saddened by that. I want that. Another one on a similar sort of theme is exclamation mark, or bang, bang. So again, if you had a non-nullable string that you were accepting as an argument, you might want to say, well, although you're saying it's non-nullable, if somebody calls you from an environment that hasn't got nullability enabled, so let's say .NET 5 or .NET 6 and they've switched off nullability, they're not going to get any warnings to tell them that they should be passing something that's not null. So you really need to do a null check on any public methods that take in a non-null string, right? And then you end up writing this, and now it looks like you're arguing with yourself. Now in C#10, obviously we've got that new method to make that nicer, but it looks like you're arguing with yourself. You're saying it's not null, but I'm going to check that it's not null. And so they're going to add some syntax, ostensibly bang bang, to say, check it for me. So basically it will write this code for us if we say exclamation mark, which just tidies things up a little bit. So that one is one that potentially could come in C#11. Another one, looking at time, I think we've got time. Another one is raw string literals, and this is what I'm really looking forward to. So this is something that we have a similar feature in F#, and it's one I really miss in C#. So if you're dealing with content like XML or JSON, if you want to kind of have that in a C# file, maybe in a test, like an assertion test or something, you know, some sort of acceptance test, it's super awkward because you have to escape stuff, and depending on whether it's a verbatim string or not, depends on how you escape it. And if you want to do XML with quotes in, you have to double quote and it gets ugly, right? And so what this feature will do is if you use triple quotes like this, and you line up the other triple quotes on the same column, this will be a raw string literal, and it will take, it will kind of ignore anything to the left of that column and give you whatever's in there as a string. So here we didn't need to escape the quote, we just paste in some XML. And what's really cool as well is this works well for JSON, right? So you can paste in a JSON object, curly braces, quotes, all the rest of it, just works. Something that's really nice about this feature is that they are going to also have it work with string interpolation. So if you added $1 at the front here, you could string interpolate in this XML, which is kind of cool. But if you think to the JSON example, the curly braces inside of your JSON are going to clash with the curly braces that break into C# with string interpolation. So what they've suggested is that there'll be the opportunity to put multiple dollars at the front. So you could put $, and that will tell the compiler how many braces you need to use consecutively to break into C#. So you use curly brace to string interpolate a JSON object, for example. And that seems a bit arbitrary, but actually that's really practical because that makes this a very usable feature. So I'm really looking forward to this one. Another C# 11 one, and this almost made it to C# 10, but they pulled it out because of some issues it caused in certain areas of the tooling, is generic attributes. I won't spend any time on this because it's exactly what you think it is. Attributes today cannot be generic. They want to make them generic. And some places where that makes a big difference is when you're using open generics. There's no way of expressing an open generic. You can't put an attribute on something using a type argument that's a generic type argument. It's a very wordy way of saying there's a very specific scenario that you can't do today that this would enable. But also for me, generic attributes just look nicer in lots of situations. Imagine sort of swashbuckle where you've got the type attribute where you say produces, in this case, produces response type. I like it as a generic argument rather than saying type of. And then finally, the last one I want to speak about is static abstracts in interfaces. And this is a super interesting one because it's shipping in C# 10, but it's shipping as a preview. And so you actually have to switch this one on, which is a relatively new thing in C#. That is something that F# has been doing for a little while now. But and the way you switch it on is you enable preview features. This feature requires runtime support. So you have to be targeting .NET 6. This is the first feature since DIMs or default interface methods that's required a runtime change. You also need to include a system.runtime.experimental package. And this is because, as I'm going to show in a bit, they've added extra interface implementations on the primitive numeric types within this feature. Which is a super scary thing to do. Hence, they've done it in a sort of a preview thing. They want customer feedback, which they're getting. And so this feature in its simplest form is you can define an interface with static abstract members, which is a new thing. And the way you'll often see it used is with this sort of recursive definition where you say I addable of T, where T is I addable of T. So it's a bit of a tricky one to get your head around. And in this case, this is kind of the feature in its plainest form. The way they're going to use this is in the primitive numeric types, they're going to have them implement these sort of maths generic interfaces. So I-addable of T, for example, I can't remember the name of them, division, multiplication, anything mathsy you can think of, they're going to add these interfaces and have the primitive numeric types implement them. So for example, we'll take int32 and have it implement it. Now int32 already has a plus operator, but they'll add the implementation for the 0 property. And that means that you can now have this sort of generic math algorithm code where you take something of this generic interface. And now you can dot on the generic type argument. So T dot some static property, which is a totally new thing. And this means you can now do very generic code, very generic math code. So think if you had to, imagine you had to write standard deviation yourself, you might want to write it for all the various numeric types. Now you could just do it once. Of course you would need to because it's out of the box, but you know what I'm saying? Like you can have generic algorithms, which is super cool. There are other use cases of this that I haven't really got my head around. One example is in the minimal, can't get my words out, in the minimal APIs that I showed earlier, one thing you could do is have parameter binding, where if you implemented a method called bind async that matched the certain generic definition, the runtime would pick it up and use it for parameter binding. That sort of convention could be defined through things like this, whereas without this feature, it's just a kind of convention you have to know about. So there's kind of other things they can do with this feature outside of the generic map space. That's kind of interesting. And that's all the features I'm going to talk about today. There's other features that I haven't touched upon that I'm just not as interested about, but you can find out about them. I've done a talk on C#5 and sorry, C#9 and .NET 5 that I'll share the link to, and I'll share the slides out. All of the stuff I've talked about is stuff that you can find out about yourself. There's a language design repo where all the language proposals are there, all the specs, all of the language design meetings, which are happening very frequently, like every few days. I check it for the, all of this content is basically based on what happens there. It's all out in the public. None of this is secret. Another great resource is this language feature status. So this is a markdown page in the Roslyn repo. And if I show you this now quickly, what's really great is it shows you all of the .NET features and what version they're going to land in. So you can see here, these are all scheduled for C#10. You've got the upcoming ones. Some of them are, yes, raw string literals. Links to the feature description, the kind of definition of them, and the branch that they're implemented in, and the status of them. So you can see some of these are going to land. And that's kind of where you can kind of get from the horse's mouth what's going on, basically. There's also Mads Torgerson's C#10 talk from 4 or 5 months back now that I'll also link out. But yeah, thanks very much for watching.